For this section of the class, I wanted to give you guys a presentation on a linear perspective, and then I'm going to lead you through exercises in 1 point, 2 point, 3 point perspective that I want you to follow along and do for your other exercise this week. So let me just talk to you first about linear perspective. So linear perspective is really a form of math and drawing that was invented in the Renaissance as a way to create illusionary space with architecture and geometric forms. And the invention of linear perspective actually comes after algebra, which is seen by some as meaning it's even more complex than something like algebra. And so you can see here, there's linear perspective employed on those stairs, in the archway there, in those vaults. And what's interesting is linear perspective is not only a device used for the illusion of two-dimensional paintings, but you can actually also map out linear perspective in the real world. That if there is a cube-shaped building out in the world, you could actually map out what it is doing in linear perspective. These rules adhere to the real world as well as in the artworks. This is another one. And so you can see as things get further away, they get smaller. That's one aspect of linear perspective. The dramatic rate at which things get smaller is pretty surprising, though. I've included in one of the links for you guys a way to map out how much smaller, say, one of those pillars gets as it gets further away. There's pretty sophisticated calculation to determine that. The Last Supper employs linear perspective, and you can see the lines all lead to the center of the painting, to Jesus's head, these angled openings all sort of aim down, and the ceiling as well, all of it's aiming there. With linear perspective, you're actually placing the viewer at a specific height and looking at a specific point. It's an early one. All right, so I've got a couple diagrams here to talk about some of the principles of linear perspective. This optical illusion shows you these blue shapes. They are the same size actually, but where they're placed on this fake road, it can make this one seem larger because our brains think spatially and can understand that something that's further away is actually bigger than it may appear to be. So that's why we have an illusion like this. The same principles at work here. Which figure is taller? This one seems like it's taller than this one, but they're actually the same height. It's just where it's placed in this linear perspective. It gives the brain the impression that this figure, by the time it reaches here in the space, is actually this big. And then the last image I have for you guys with linear perspective is just to show you an ellipse that you're looking down at a Coca-Cola bottle. Depending on the angle at which you're looking at that opening, straight down would be a circle. And then as it tilts, it's going to create these ellipses of varying proportions to the width and the height. But one thing to keep in mind is the width is always the same, and it's just the dimension of the height is shrinking as that angle shifts until you're looking exactly eye level at the opening, and it looks like that at the bottom. So I just wanted to show you guys that too. So those are just some examples of classical linear perspective. And so now I'm going to lead you guys through how to do 1 point, 2 point, 3 point perspective and a couple of things within that. So with linear perspective, you always need to have what is called the horizon line. And what the horizon line is the eye level of your viewer. This is where they are looking at their eye level. And then you're also going to place something called a vanishing point, which is exactly where they will be looking. That is the vanishing point. You got your horizon line, your vanishing point, and then I'm going to go over a 1-point perspective first. So with 1-point perspective, all lines are either going perfectly straight up and down, perfectly horizontal, or they're aiming at the vanishing point. And so I'll show you what that means. So we're going to teach you 1-point, 2-point, and 3-point perspective. I'm going to use a box, and so I want you to follow along. Once you have your horizon line or your vanishing point, I want you to draw the frontally facing side of a box. And so you want to use a ruler for this. And so what we're looking at here, if you can imagine, this is the front facing side of a box. And in 1-point perspective, all lines are either perfectly vertical, perfectly horizontal, or aiming towards the vanishing point. So if this is the front of our box, now we have to complete looking at the sides and the top of the box. So what you're going to do, once you have the front side of your box, is connect all the corners to the vanishing point. And I want you to use light pressure because you'll be erasing part of these lines. So I'm using the soft charcoal just because it's a light material. You're also welcome to use your graphite pencils. So all the lines that I could see connecting to the vanishing point, I connected them, these two. If I did this one, it would go behind the box. So this is not a translucent box, so I'm not going to draw that one. So once you've drawn the front of your box and you've connected the corners to the vanishing point, what you're going to do then is you're going to decide where the end of the box is. So I want the top of my box to end here. So I'm going to create a perfectly horizontal line. And then where it meets this line, I'm going to make a perfectly vertical line. And then I'm going to erase out the lines that are not the box. And that is a box in 1-point perspective. And so because it's below, or we're seeing the top of it, and because it's to the right of our vanishing point, we're seeing the left side. So I want you to do several boxes like this in 1-point perspective and place them at different places around the vanishing point in that horizon line. So here I'm gonna make one above the horizon line. So in 1-point perspective, all lines are either perfectly vertical, perfectly horizontal, or aiming towards the vanishing point. So now I'm going to take all those visible corners and bring them to my vanishing point. I'm going to do a perfectly vertical line to decide where my box ends. And then at that joint, I'm going to create a perfectly horizontal line. And then I'm going to erase out what's not the box. And there's my 1-point perspective box above the horizon line. A box can even be placed on the horizon line. Perfectly vertical, perfectly horizontal, front facing side of the box. And then any that we can see aiming towards the vanishing point. And since it is on the horizon line, we're actually only going to get to see that right side. So one last thing I want you guys to do with 1-point perspective, and 1-point perspective is my favorite. You can employ it. A lot of those images I showed you from the Renaissance, those were just 1-point perspective, a lot of them, and a lot can be done with just 1-point perspective. So I want to just show you guys lastly that you can create a non-box shape, but one thing to keep in mind is this shape needs to have one side frontally facing you, because in 1-point perspective, you're always seeing the front side of something. That's why the lines are always either perfectly vertical, perfectly horizontal, or aiming towards the vanishing point. So this is the front face of my object. Now I can trace all my lines over to the vanishing point. And I'm not even going to bring them all the way to it because my shape isn't going to be that large. Okay, so all the lines are either perfectly vertical, perfectly horizontal, or now aiming towards the vanishing point. So now I'm going to end the back side of my shape. So with a perfect vertical, I'm going to end it. Now we see the left side of it. I'm going to end it up here at the junction. I'm going to end it here. And there's a logic to this once you kind of understand what's going on. Oops. And then to break the top, perfect vertical. And so there's my wacky shape in 1 point perspective. So I want you guys to do a couple boxes, and then I want you to try to do an unusual shape. Make sure that it's geometric. Like rounded forms can be worked into linear perspective, but just for our purposes for now, I want you guys to just stick with rigid forms. So that's 1 point perspective. So next, I'm going to show you guys how to do 2 point perspective. So with 2 point perspective, you still have your horizon line. But with 2 point perspective, you're actually going to have 2 vanishing points, vanishing point 1 and vanishing point 2. And so with 2 point perspective, all lines are either perfectly vertical or aiming at one of the 2 vanishing points. So it's different from 1 point perspective, which has everything either perfectly vertical and horizontal or aiming to the vanishing point. Now we only have perfect verticals, and the rest of the lines are aiming towards either one of these 2 vanishing points. And so with 1 point perspective, you were looking at the front facing side of your object. But with 2 point perspective, you are looking directly at an edge of the object, the side of the object. So we're going to do our box again. And the way you start a box in 2 point perspective, as opposed to 1 point, is with the edge of it. So this is now the height of our box, and this is the edge of it. So with 2 point perspective, all lines are either perfectly vertical or they're aiming towards the vanishing points. So now I'm going to bring the top and bottom of my line to both of the vanishing points. Remember to go lightly. You can always darken lines later. And so now we've got the sides of our box, and I'm going to arbitrarily decide that the box ends here. So with the perfect vertical, because all lines in 2 point perspective are either perfectly vertical or aiming towards the 2 vanishing points. So now that this, the end of my box is decided, I'm going to take that point where the end of the box reaches side, and I'm going to bring that corner to the other vanishing point. And then I'm going to decide where my box ends on the left. So it ends here. And then I'm going to bring that corner up to the other vanishing point, and then erase all the lines that are not the box. And this is 2 point perspective. So this gives you the illusion that you're looking at the side of the box, as opposed to 1 point perspective, which gives you the front. So this is 2 point perspective. I'm going to do a couple more just to show you what they might look like at different angles. So here, let's go even further from the vanishing point so you guys can see that it exposes more of the top. So I've got the edge of my box. I'm going to bring the top and the bottom to the vanishing points. Vanishing point 1 and vanishing point 2. I'm going to arbitrarily end my box here with a perfect vertical and here with perfect vertical. And then where those lines meet, they're going to connect to the opposite vanishing point. And here I'm actually creating the illusion that that first box is above the other one based on the overlap. So this is my second box. And you can see there's a more dramatic view of the top because it's further away from those vanishing points. All right, and let's do one more. Let's make it pretty dramatically to the left. So we've got our top and bottom of the edge. All lines are either perfectly vertical or headed towards the vanishing points. I'm going to end my box here, perfect vertical, and here. And then those back corners should flip to the other vanishing points. It's a little cramped because it's so close to the horizon line, but that's our next 2-point perspective box up there. Now we can see the underside of it because it's above the vanishing point slightly. So now we're on to 3-point perspective. And so if you remember 1-point perspective, all lines are either perfectly vertical, perfectly horizontal, or aiming towards the vanishing point. With 2-point perspective, all lines are either perfectly vertical or aiming towards vanishing point 1 or vanishing point 2. And with 3-point perspective, all lines are headed towards either vanishing point 1, vanishing point 2, or vanishing point 3. So let me just show you what that looks like. So 3-point perspective is used to show extreme distortion from above or below. So it's really useful for things like skyscrapers or cityscape from above or below is the sort of main use for it. So I'm going to start out, and I'm just going to start out with a perfect vertical. This is the edge of our skyscraper. And so it's headed towards vanishing point 3. And then I'm going to take the top and the bottoms to vanishing point 2. And the top and the bottom to vanishing point 1. Okay. Oops. Okay, so now here's the trick with 3-point perspective. With 2-point perspective, we would have gone straight up and down to end our box or our skyscraper. But here, we're actually going to be aiming them towards vanishing point 3. So to end the side of our box, which is now a skyscraper, I'm actually aiming it towards vanishing point 3, not going straight up and down. And that's where it becomes 3-point perspective. And so you can see it's a lot more dramatic. And so then now we've got these points to crisscross against the other vanishing points. And that is our box in 3-point perspective, or our skyscraper. And let me just show you how I do windows on this guy. And this also can be done upside down, where vanishing point 3 is above, and it gets smaller the other way. So if I wanted to do a window on either side of this, I would be aiming towards vanishing point 3 to get my sides. Get the back too. And then bottom of my window should be headed towards vanishing point 2. So that is a window in 3-point perspective. And I could do a door in 3-point perspective over here, aiming towards vanishing point 3. Ending at vanishing point 1. So that, very briefly, is 3-point perspective. 1 and 2 are a lot more common. That is 3-point perspective. So now we're at the last exercise with linear perspective I wanted to teach you guys today, and you'll have to follow along with this one as well. In this exercise, I show you guys how to draw a room interior in linear perspective, and then how to create a checkerboard floor. So let's get started. This is going to be 1-point perspective. So I'm putting my vanishing point just in the center. I've got my light horizon line. And the first thing you guys are going to do for your room in 1-point perspective is to create the back wall. And so you need to give yourself enough space because the back wall is going to be much smaller proportionately to the rest of the room. And so if you kind of eyeball something a little similar to my page, you should be okay. I wouldn't go too much bigger than this. This is just the back far wall. So you start out with that back wall, and I would put the horizon line somewhere inside it and the vanishing point. And then what you're going to do is go from the vanishing point out through the 4 corners. You might want to go pretty much to the edge of your page. And this is calculating out your floor, ceiling, and sidewalls. So once you have lines going from the vanishing point through all the corners of the back wall, you can end your floor, ceiling, and sidewalls. So here I am using a perfect horizontal. Here I'm using a perfect vertical because this is 1-point perspective. Then complete the ceiling. All right, so now we are looking at our room in 1-point perspective. And so let me just show you what I would do to put in a window and a door and things like that, because I want you guys to do that as well. So let's put a window here. All you need to do is show the edge of your window, and then you're going to connect the vanishing point to the top and the bottom of that line. Then you decide where that window ends. So I'm going to end it over here. There's anything on this wall or the ceiling and the floor needs to be mapped out in linear perspective. But if we were to do a door on the back wall, it would just be perfect verticals and perfect horizontals. There's no perspective because it's frontally facing. All right, so now I'm going to show you guys how to do the checkerboard floor. So what you're going to need to do first is break up that front wall into even units. So I'm just going to give myself 2-inch measurements. So once you've broken up that front edge wall into even measurements, then what you're going to do is you're going to aim all of those measurements to the vanishing point, and I would just stop the line at the end of your floor. This is now the checkerboard floor coming in. Linear perspective can be used to map out arches, roofs, barn doors, vaults. There's links to all these things. So I'm just quickly going over the basics, but you guys, if you're interested in linear perspective, if you just Google how to draw a roof in linear perspective, for example, there are the formulae for a lot of different things. All right, so now that all the lines are aiming towards the vantage point, what you're going to do then is you're going to go from the front left corner of your floor to the back right corner and draw a line through it, and a light line. And basically everywhere where that line is hitting one of your lines aiming towards the vanishing point, that is where you put the perfect horizontal. That's the next row of tiles. So you guys can see after you guys mark an even measurement of the front edge of that floor, then at each of those points, you're going to mark them, draw a line to the vanishing point. Then you're going to draw a line lightly from the front left corner to back right. Then everywhere where that intersecting line is hitting all of these lines, that is where the next row goes in horizontally. So that is your room in linear perspective in the checkerboard floor.